Imagine you're running an industrial plant where precision is everything. What if I told you that the speed at which your control system processes information could make or break your operations? Today, we're diving deep into an essential concept: scan time in PLC and DCS. Why is PLC scan time fixed while DCS scan time varies? Let's find out. First, let's quickly understand what a scan cycle is. A PLC, programmable logic controller, and a DCS, distributed control system, both continuously scan data, process logic, and send outputs. This cycle repeats endlessly to control industrial processes. But here's the key difference. PLC scan time is fixed, while DCS scan time is variable. Why? In a PLC, real-time deterministic control is crucial. It executes a fixed scan cycle where inputs are fixed and are read, logic is processed, and outputs are updated which are fixed, all within a predefined time. This is essential for processes like robotic arms, conveyor belts, or high-speed sorting systems, where digital inputs and digital outputs are in large quantity and are monitored at equal time intervals. Any delay or inconsistency could lead to machine failure or product defects. Though there may be analog inputs and outputs and some PID loops as well, the numbers will be low. That's why the addition of new PID loops slows down PLC scan time every time, as it takes much processing time. For example, if a PLC is controlling a fast-moving conveyor belt, the scan time must be predictable, let's say 10 milliseconds. Every 10 ms, it reads sensors, executes logic, and updates outputs. If scan time fluctuates, the system could misalign products or even cause breakdowns. That's why PLC scan time is kept fixed. Over a period of time, you may have added new inputs and outputs to the process, and definitely it would have increased scan time a bit more, but it is fixed. In a PLC, the scan time is generally deterministic, fixed, but it can vary dynamically due to program complexity. More logic instructions increase scan time. Number of I/O devices, more inputs, outputs to process extend scan duration. Communication load, external communication, Ethernet, Modbus, Profibus, can slow down the cycle. Interrupts or events. High priority tasks may cause scan time fluctuations. Timers and loops. Nested loops and large timer operations affect execution time. If a simple PLC program has a scan time of 10 minutes, but receives more data from sensors or executes additional logic, the scan time may increase to 20 minutes dynamically. On the other hand, a DCS is designed for large-scale process control, such as oil refineries, power plants, and chemical industries. These systems manage multiple loops all the time, each with different priorities. Unlike PLCs, DCS scan time is variable to optimize performance and reduce system load. In a distributed control system, DCS, scan time varies more due to multi-loop execution, multiple process loops running simultaneously. Different scan priorities. Critical loops, like PID control, execute faster than less critical tasks. Network communication delays. Data exchange between controllers, operator stations, and field devices impacts timing. System load variations. More connected devices and larger process configurations affect scan efficiency. Let's take two examples. Boiler pressure control. It's a fast-changing variable. A delay in scanning could lead to a dangerous pressure surge, so the scan cycle is set to 100 milliseconds. Likewise, vibration is a fast-changing parameter, and so on. A DCS handling temperature control loops may have a fast scan time, 100 millimeters for PID loops, while monitoring tasks, alarms, data logging may run every 500 millimeters to 1 sec, dynamically adjusting based on system demand. Now consider storage tank level monitoring. Liquid levels change slowly, so checking every 2 seconds is sufficient. Basically, you're reducing CPU load. This flexibility in scan time allows a DCS to prioritize critical loops while managing thousands of control loops efficiently. Unlike PLCs, where there are no PID loops or there are limited numbers of PID loops, where a fixed scan time ensures rapid, consistent control, a DCS adapts to process needs dynamically. So, to wrap it up, PLCs need fixed scan times for precision and high-speed control, while DCS uses variable scan times to optimize performance across multiple process loops. Both approaches are designed to ensure smooth, safe, and efficient industrial automation. I hope this breakdown helped you understand why scan time is a critical factor in automation. If you found this video useful, hit the like button, subscribe for more industrial automation insights, and share this with your colleagues and friends. Let's keep learning together. See you in the next one.